Hi, I'm Eric. Welcome back to my channel. Today I'm uh, going to perform the motor acceleration analysis. So there are two different type of function that you can use in ETAP uh, to modeling, or let's say to simulate the motor starting situation. So first one is dynamic motor starting, and the second one is static motor starting. So we always begin with the static motor starting. Then we make sure everything is fine. Then we run dynamic motor starting. So first, we need to start with our single line diagram. So I already draw my single line diagram here. So we start from this one. We start from this one, power grid, and as usual, uh, we select maybe 10,000, and XR ratio we select 6. Then we push OK. Then we have a transformer rating here. I already set up for this. I think you should be able to set up this parameter. So the primary side is 11 kilovolt. Secondary side is 0. It's 415 volts, and the impedance we just use the typical number and also typical number here. Yeah, this is a transformer. Okay, and for the cable here, we choose. Let's go to configuration. For the transformer, you can see here is a library, and I choose this one. I choose this one, and also the sizing I choose 250, and you press OK. It's not a big deal for this study. It's just then for a circuit breaker, I choose this quarter hammer. You can choose whatever you like. ETAP they provide really really a lot of different types of circuit breaker from different manufacturer. You can see we have ABB here, but I choose Koto Hammer here. I think that, yeah, they also have Siemens circuit breaker, and I choose this one. You can choose whatever you need here. And for motor, uh, we just put either 100 horsepower here, and you need to go to a model, then library, and choose this one, then you press see 100 horsepower, 100 kilowatt, and 2 ports. So you just press OK, then you they have a parameter here. So if you have your own manufacturer, then you can just type in uh, the parameter you need. Or you just like me doing some study or simulation, then you can just choose from your library, and it will shows uh, its parameter and also the circuit here. And there are also some plot with its motor slip, you can take a look. And I just I just click update, then it will automatically implement parameters in this model to our motor. Then update, then press OK. And then here I use 200 kilowatts or 200 horsepower, and you choose the model you need here, and you click update, and don't forget to also put this parameter. Same here, we have synchronous motor, then use also 200 horsepower, and also 0.4, 0.1, 0.41, so 0.91 here. Then you check the power flow. Okay, then you can see everything is fine, and yeah, we can just use our. So you can see the current go through this induction motor and synchronous motor here. Then we after make sure power flow is fine, then we go to a motor station here. So we started from run static motor starting. So after calculation, let's see after. Sorry, I forgot to explain one step. So before you run this, you have to define when will this motor started in your study case. So for me, you click edit study case, then you click event, then you put event 1 here. Let me just delete it and show you guys again. So you add activity 1 event as name this event as Q1, then it will happen on 1 second, and also you edit what happened in 1 second on 1 second. So on 1 second I started motor 1, so you can see element type motor. I start motor 1. You can also do other type of you can also active other type of element, but we only have motor in this case. So we start motor 1, and then you can see we start motor 1 on this bus. Then I add another event as Q2 on 2 seconds, and I add the action. I started motor 2 on 2 seconds here, and I add another one. So remember the timeline. So same here. I started a synchronous motor here, and yeah. Then the total simulation time, I put it as maybe 10 seconds. Okay. Then you click OK after you edit your study case. Then you run a static motor starting first to see what will happen. So here is our starting time slider. So when we start to around 1 second, you can see the current. We just started our motor 1. And then when I go to 2 seconds, you can see I started motor 2. And when I go to 3 seconds, you can see I started motor 3. So the current will not change very significantly in a static case, but we can also see the plot. Let's open our plot manager here. So it takes a while. It takes a while, I think. I think it already opened here. Sorry. So let's see our bus. Let's see bus 3 voltage plot. So as you can see, there will be a small voltage drop on. There will be a small voltage drop around 1% when you opened you started motor 1. Then there will be also a small voltage drop on when you started motor 2, and there will be a more deep voltage drop when you started dynamic synchronous motor. Then go back to normal. Of course, you will have a voltage drop due to you increasing the load on bus 3. But as you can see, it's still above 99.5%, which is pretty nice. But we can see another study case in a dynamic one. So let me just close our plot manager first. Then I click Run Dynamic Motor Starting. So in a dynamic motor starting, the motor will the current will increase a lot, then drop to normal, drop to drop to normal. So you can see that's time when we do static motor starting. The motor 1 begin at around current 127 m, something like that. But you can see the motor 1, if you do a dynamic simulation, then motor 1 will have a really big current at the beginning, then drop to normal. So as you can see, when the time passes away, this motor current drop from 7 something to 600 something. Then when we started on the 2 second, we started motor 2, and you can see it's also a very big starting current on motor 2. And you can see the motor 1 continuing decrease its current. Then both of the voltage currents will drop until it become normal. And also same in this synchronous motor 3. It started with 1,500 something. Then they will continue go back to normal. As you can see now, the motor 1 go back to normal, and motor 2 also go back to normal after couples of seconds. But we can see what is the influence for our bus in this case. So we also go to motor starting the product manager. So let's see our product manager. Then we check our bus 3 first, the voltage. So you can see the voltage drop and increase a little bit, and then when motor 2 start, it drops very significantly again, then go back to normal. No, it's not normal, but go back a little bit. Then when the synonymous motor started, it dropped more significantly, then go back very slowly. Then then we can see the motor current. Maybe see sleep and also its current, motor 1. So as you can see, the sleep percentage at the beginning, it was 100%. That means the speed between the starter and the router was the differences between starter and router means sleep. You can Google it. What is definition of sleep for motor? So it was 100% at the beginning, then it dropped to 0 after around 4.5 seconds for motor 1. And in this case, we start our motor at 1 second. So you can see the current it's 600 something at the beginning, then it will drop and go to static at around 4 seconds. For motor 2, we can take a look. So for motor 2, let me close motor 1 first. It will have the same situation here. We started at 2 seconds, then the sleep rate just drop. Then it will become normal, or let's say static, are around 5.5 seconds. You can see the x-axis here. Then let's check synonymous motor on the product manager. So as you can see, it takes a while for a synonymous motor go to a flat line. It takes a while. It hasn't finished on 10 seconds. So this is how we do motor starting analyze. I hope you like this video. See you next time. Bye bye.